In the last class, we went through the derivation of DIT FFT algorithm for considering n as 8, and we have understood in-place computation method wherein the input signals are bit reversed and the output signals are kept in order. Okay, and we have seen the reduction method where we have reduced the number of multiplication with a twiddle factor. We have reduced that multiplication by just replacing -1. Okay, that reduction method is also called as Cooley-Turkey algorithm. Okay, this is the flow graph of DIT FFT algorithm which we have to use to compute DFT of a particular signal considering n as 8. Okay, in this diagram only you can see where input signals, can you see this input signal x of 0, instead of x of 1 x of 4 is written according to which method? In place computation method. Okay, instead of x of 2 again x of 2, instead of x of 3 x of 6, instead of x of 4 x of 1, instead of x of 5 it is x of 5 only, instead of x of 6 it is x of 3, instead of x of 7 it is x of 7 only. Okay, so this particular structure is called as butterfly structure. Okay, so how many butterfly structures we have? 1, 2, 3 and 4, and here also. So this one butterfly structure, inside one more butterfly structure. So there are 2 butterfly structures. Here also 2 butterfly structures, and here we have 4 butterfly structures which are overlapped with each other. So 4 plus 4 plus 4. So totally we have how many butterfly structures here? 4 3s are 12 butterfly structures. Okay, for each butterfly structure 2 inputs and 2 outputs. So can you see this 2 line joining point? This indicates addition. Okay, each arrow mark indicates multiplication. So how many additions and multiplications are present here? So this is one joining point, 1, 2, 3, 4, 5, 6, 7 and 8. Here also 8. 1, 2, 3, 4, 5, 6, 7, 8. Here also 8. Totally 8 plus 8 plus 8. That is 8 3s are 24 additions we have in this particular flow graph for considering n as 8-point DFT. So how many multiplications we have here? So this is one multiplication, 1, 2, 3, 4, 5, 6, 7 and 8, 9, 10, 11 and 12, and this 13, 14, 15 and 16, 17, 18, 19, 20 and these 4, 24. So totally we have the number of multiplications in DIT FFT flow graph 24. Okay, so this is how the number of additions and number of multiplications are calculated with respect to flow graph of DIT FFT algorithm by considering n as 8. Okay, now as we have discussed in this diagram itself, how many intermediary values we have? A of 0, A of 1, B of 0, B of 1, C of 0, C of 1, D of 0, D of 1, G of 0, G of 1 till G of 3, H of 0 till H of 3. So how many intermediate results are to be held in registers? So here 4, 8, here 8. Totally 16 number of registers are required for n equal to 8 to hold the intermediary results. Remember this. Okay, for n equal to 8. So this is the final structure we have to use to compute DFT of a particular input signal x of n. Now we'll take one example. First example. So given x of n 0, 1, 2, 3. Find x of k using DIT FFT algorithm. In this structure, only this part depicts 4-point DFT. This whole part depicts 8-point DFT. So I'll take only this part. Okay. So input signals are bit reversed, isn't it? So this is x of 0, x of 2, x of 1 and x of 3. Okay. Here x of 1 is replaced with x of 2. This is 4-point DFT. So 2 to the power 2, 0, 0, 0, 1, 1, 0 and 1, 1. Isn't it? So if I replace 0, 0 with again reverse, then you will get 0 only. 0, 1 is if I reversed, you will get 2. So x of 2, x of 1 is written as x of 2. X of 1, 0, 1. If you reverse 0, 1, you will get 1, 0. 1, 0 is 2. So instead of x of 2, x of 1 is written. And 3 is 1, 1. If you reverse also, you will get 3 only. So x of 3 will be x of 3 itself, no change. So according to in-place computation, input signal x of n is bit reversed. Okay. So x of 0 is what? 0. X of 2 is what? 2. X of 1 is 1. X of 3 is 3. So this is one butterfly diagram. Now how to calculate this intermediate result? So this is 0. Okay. Next, this is 2. 2 into omega 4 is to 0 is again 2 into 1. Omega 4 is to 0 is 1. So 2 into 1 plus 0, that is 0 plus 2, you will get 2. Similarly here, this line, so this value is coming here 0. This 2 into 1 into minus 1. Okay, we have to multiply this. Arrow marks indicates multiplication. So 2 into 1 into minus 1, you will get 0 minus 2 at this point. So answer is minus 2. Similarly, remaining two values, x of 1 till this you are getting 1. Now this twiddle factor is 1. 1 into 3. 1 plus 3, that is 4. At this point you are getting 4 as answer. So here 1. 3 into 1 into minus 1, that is 1 minus 3. So you will get here minus 2. Okay. Similarly, this value is passed here. So at this point we have 2, at this point we have minus 2, at this point we have plus 4, at this point we have again minus 2 into minus j. So can you see these intermediary values? Omega 4 is to 0, that is 1. 1 has to be multiplied with 4. So you will get at this point 4. Here it is minus 2. Minus 2 has to be multiplied with minus j. So you will get plus j2 at this point. Plus j2 at this point. So this 2 is passed here 2. And this 4 into 1 is passed and added. So 2 plus 4, that is 6 is the answer for x of 0. Similarly, this minus 2 is passed at this point, and then minus 2 into minus j, that is plus j2. So minus 2 plus j2 is x of 1. Similarly, 4 into 1, that is 4, into minus 1, that is minus 4, and this plus 2 is passed here. So this plus 2 and this minus 4. You will get minus 2 as x of 2. The last one. So this minus 2 is passed here at this point. Then minus 2 into minus j into minus 1. You will get minus j2. Always remember, this point indicates addition. Each arrow mark indicates multiplication. So minus 2 minus j2 is x of 3. So totally you are getting DFT of a sequence x of n as 0, of 0, 1, 2, 3 as x of k is equal to 6. Minus 2 plus j2, minus 2, minus 2, minus j2. So this is your DFT answer. Similarly, one more example we'll take. Given is x of n is equal to 2, 1, 2, 1. Find x of k using DIT FFT algorithm. Okay. So this is again 4-point DFT. Only this part is taken. So x of 0 is written as x of 0 only. So x of 0 is 2. X of 1 is written as x of 2 according to in-place computation. So x of 2 is again 2. X of 1, that is x of 2 is replaced with x of 1. So x of 1 is 1. X of 3 is 1. So this is 1, this is 1. We know this. This is 1 and this is minus j. Now we will get the answer for this is 2 plus 2 into 1, that is 2. 2 plus 2 is 4. At this point, this 2 minus 2, so you will get 0. 1 into 1 is 1, so you will get 2. So this is 1 and this is minus 1, you will get 0. Okay. Now at this point we have what? 4, 0, and here 2 into 1 again 2, and 0 into anything is again 0 here. So in this point we have 0. So here 4 is passed and here 2 into 1, 2 is passed. 4 plus 2 you will get 6. Similarly, this 0 and this 0. So you will get 0 only. 0 plus 0 is 0. Next, at this point, from the top you will get 4, 2 into 1 into minus 2, that is 4 minus 2, you will get 2. Similarly, at this point we have from here 0 and from here again 0. So we will get 0. So answer for this is 6, 0, 2 and 0. So this is the DFT of x of n 2 1 2 1 sequence. Okay. So after this, now we will take 8-point DFT of a sequence. X of n is given by 0, 1, 2, 3, 4, 5, 6 and 7. Find x of k using DIT FFT. When the DIT FFT is mentioned, then you have to draw the entire diagram, flow graph. Okay. X of 0 is replaced with x of 0 only. X of 0 is 0. Next, x of 2 is replaced by x of 4. X of 4 is 4. X of 2 is replaced with x of 2 only. So x of 2 is 2. X of 3 is replaced by x of 6. So x of 6 is 6. X of 4 is replaced by x of 1. X of 1 is 1. X of 5 is replaced by x of 5 itself. So x of 5 is 5. X of 6 is replaced by x of 3. So x of 3 is 3. X of 7 is replaced with x of 7, then x of 7 is 7. So here instead of omega 4 raised to 0, we have omega 8 raised to 0 because we are computing DFT of 8-point equation. Yes. So that is this omega 8 raised to 0 is again 1, omega 8 raised to 0 is 1, omega 8 raised to 0 is 1 and here. But here omega 8 raised to 2 is omega 4 raised to 1, that is minus j. Okay. Similarly here omega 8 raised to 0 is 1, omega 8 raised to 1 is according to this diagram. So omega 8 raised to 1 is 1 upon root 2 minus j upon root 2. So we can write omega 8 raised to 1 as 1 upon root 2 minus j upon root 2. Omega 8 raised to 2 is omega 4 raised to 1 only. So it is minus j. Next omega 8 raised to 3. Omega 8 raised to 3 in this equation is given by minus 1 upon root 2 minus j upon root 2. So this is minus 1 upon root 2 minus j upon root 2. Can you see this? After writing this equation, let's start with the computation. So at this point you will get x of 0, that is 0, plus 4 into 1, that is 4. So 0 plus 4 is 4. 0, 4 into 1 into minus 4, that is 0 minus 4, that is minus 4 at this point. Similarly 2 plus 6 into 1, that is 2 plus 6, that is 8. At this point we have 8. Next 2, 6 into 1 into minus 6, 2 minus 6, that is minus 4 at this point into minus j. Remember this. So this arrow mark indicates multiplication and this arrow mark holds minus j value. Similarly, at this point we have 1 plus 5 into 1, that is plus 6 at this point. 1 minus 5, that is minus 4 at this point. 3 plus 7, that is 10 at this point. 3 minus 7, that is minus 4 at this point. And this at this point, this minus 4 need to be multiplied with minus j. So we have plus 4j at this point, 10 at this point, minus 4 at this point, 6 at this point, plus j4 at this point, 8 at this point, minus 4 at this point and 4 at this point. At this point we have 4 plus this 8 into 1, that is 12. Next this minus 4 into plus j4 at this point. Similarly this 4 minus 8, you will get minus 4. So this minus 4 and this plus j4 into minus 1, that is minus j4. At this point 6 plus this 10, so you will get 16. So minus 4 and this minus 4 into minus j, that is plus j4. At this point we have minus 10 plus 6, so minus 4. Next minus 4 into minus j into minus 1, that is minus 4 minus j4. Okay. Now at this point we have this 12 and this 16 into 1. 12 plus 16, you will get 28. Similarly, at this point we have minus 4 plus j4 and go to this point. So here we have two values. One is minus 4 plus j4 into 1 upon root 2 minus j upon root 2. When you multiply this, you will get the answer for this, and that is added with this minus 4 plus j4. So you will get minus 4 plus j 9.67. Use your calci, put these values. This minus 4 plus j4 is added with what? Multiplication of minus 4 plus j4 into 1 upon root 2 minus j upon root 2. So when you do this computation using calci, you will get minus 4 plus j 9.67. So at this point, you have minus 4 and here it is plus j4. So minus 4 plus j4. At this point, we have minus 4 minus j4 into plus multiplication of these two, that is minus 4 minus j4 into minus 1 upon root 2 minus j upon root 2. When you multiply these two and you add with this, you will get minus 4 plus j 1.66. So at this point we have 16 into 1 into minus 1, that is minus 16 plus 12. So we will get minus 4 as an answer for x of 4. Similarly, for x of 5, we have these two multiplication into minus 1. Okay, these two multiplication with minus 1 plus minus 4 plus j4. When you compute using calci, you will get minus 4 minus j 1 plus 1.66. Okay, so remember this, x of 5 is computed with addition of this minus 4 plus j4 with multiplication of this minus 4 plus j4 into 1 upon root 2 minus j upon root 2 into minus 1. So you will get this. So better you do what? You compute till x of 0 to x of 4. Okay, x of 4. X of 5 is just complex conjugate of x of 3. So this value, only sign of complex part you have to change. You need not have to compute x of 5, x of 6 and x of 7. It is just a conjugate of x of 3, x of 2 and x of 1 respectively. X of 5 is conjugate of x of 3, that is minus 4 minus j 1.66. Even x of 6 is conjugate of x of 2, that is minus 4 minus j 4. X of 7 is conjugate of x of 1, that is minus 4 minus j 9.66. So you just have to compute x of 0, x of 1, x of 2, x of 3 and x of 4 properly using your calci. After doing that, just replace x of 5 with the conjugate of x of 3, x of 6 with the conjugate of x of 2, x of 7 with the conjugate of x of 1. So this completes example 3. So same, x of n is taken as 2 raised to n, where n ranges from 0 to 7. So you will have to find out 8-point DFT of this x of n sequence, that is 2 raised to n. Okay, just write x of 0 as, so when I replace this x of n, so you will get what? 0. First you have to consider n as 0. So 2 raised to 0 is 1. So x of 0 is 1. 2 raised to 1 is 2. 2 raised to 2 is 4. 2 raised to 3 is 8. Okay, first replace that value. So you will get what here? Sequence as, first you will get 1, then you will get 2 raised to 1 is 2, then you will get 2 raised to 2 as 4, then you will get 8, then you will get 16, then you will get 32, then 64, then you will get 128. So this is x of 0, x of 1, x of 2, x of 3, x of 4, x of 5, x of 6 and x of 7. So x of 0 is 1, x of 2 is replaced by x of 4, x of 4 is 16, x of 2 is 4, x of 6 is 64, x of 1 is 2, x of 5 is 32, x of 3 is 8, x of 7 is 128. At this point we have 1 plus 16, that is 17. At this point we have 1 minus 16, that is minus 15. At this point we have 4 plus 64, that is 68. and at this point we have 4 minus 64, that is minus 60. At this point we have 2 plus 32, that is 34. At this point we have 2 minus 32, that is minus 30. Similarly here 136 and minus 120. And here this minus 60 is multiplied with minus j, and this minus 120 is multiplied with minus j. So at this point we have 17 minus 15, 68, and this is plus j 60, and this is 34, this is minus 30, and this is 136, and this is plus j 120. So at this point we have 17 plus 68, that is 85, minus 15 plus j 60. At this point we have minus 68 plus 17, that is minus 51. At this point we have minus 15 minus j 60. Why it is minus j 60? Minus into minus plus 60j into minus, that is minus 60j. So this is 34 plus 136, you will get 170, and this is minus 30, minus into minus plus j 20, and this is 136, that has to be multiplied with minus, so minus 136 plus 34, you will get minus 102. At this point we have minus 30, minus into minus, that is minus j 120. At this point, for this factor minus 30 plus j 120, you have to multiply 1 upon root 2 minus j upon root 2. Similarly for this you have to multiply minus 1 upon root 2 minus j upon root 2. So at this point we will get what? 85 plus 170, that is 255. At this point we have to multiply, first we have to multiply this with this plus minus 15 plus j 60, you will get this answer. Similarly x of 2 minus 51 need to be added with minus into minus plus j 102. So you will get minus 51 plus j 102. X of 3. So this factor, that is minus 15 minus j 60, is to be added with multiplication of this and this. When you compute, you will get this answer. Minus 78 plus j 46.04. X of 5. So this is minus 170, this is plus 85, that is minus 85. So don't compute x of 5, x of 6, x of 7. Here x of 5 is conjugate of x of 3, that is minus 78 minus j 46.04. X of 6 is conjugate of x of 2, that is minus 51 minus j 102. Instead of plus, you should write minus here. X of 7 is conjugate of x of 1, that is 48.63 minus j 166.05. So this completes computation of x of k using DIT FFT radix 2 algorithm.